In this section, we are going to discuss about parallelogram and their properties. First, let's see the definition of a parallelogram. A parallelogram is a flat shape with 4 straight connected sides so that opposite sides are equal and parallel. This means a parallelogram is a plane figure as well as a closed shape as well as it's a quadrilateral. You can have almost all of these qualities and still not have a parallelogram. If the 4 sides do not connect at their end points, you do not have a closed shape. No parallelogram. If one side is longer than its opposite side, you do not have a parallel side. Then there is a no parallelogram. If only one set of opposite sides are congruent, you do not have a parallelogram. So, the name parallelogram gives away one of its identifying property, that is 2 pairs of equal and parallel opposite sides. Example, given a parallelogram ABCD, a parallelogram has 4 vertices A, B, C and D. Now, what are the 4 sides? AB, BC, CD and DA. Now, what are the 4 angles? Angle A, angle B, angle C and angle D. Now, the 2 diagonals, that is AC and BD. Next, we will discuss about the family of parallelograms. First one, rhombus, or it is sometimes called a diamond, a parallelogram with 4 equal sides. Next is a rectangle, a parallelogram with opposite sides equal and 4 equal angles. Third one, square, a parallelogram with 4 equal sides and 4 equal angles. Now, let's discuss the properties of a parallelogram. Parallelograms have some interesting properties based on their diagonal sides and angles. First property, a diagonal of a parallelogram divides it into 2 congruent triangles. Diagonal PR divides PQRS into 2 triangles, triangle PQR and triangle PSR. Second property, opposite sides are equal. PQ is equal to SR, QR is equal to PS. Next, third one, opposite angles are equal. Angle P equal to angle R, angle Q is equal to angle S. Fourth property, diagonals of a parallelogram bisect each other. Diagonal PR and diagonal QS bisect each other. Now, we need to see the proof of each property. Theorem number 1. A diagonal of a parallelogram divides it into 2 congruent triangles. Given a parallelogram ABCD, what is the construction we have to do? Join AC so that AC forms a diagonal and divides the parallelogram ABCD into 2 triangles, that is triangle ABC and triangle CDA. Now, we need to prove the 2 triangles ABC and triangle ADC are congruent triangles. Proof. Opposite sides of a parallelogram are parallel. So, BC parallel to AD with AC as the transversal, we can say angle BCA is equal to angle DAC. What is the reason? They are alternate angles. Mark it as equation number 1. Next, AB parallel to DC with AC as the transversal, angle BAC is equal to angle DCA. Reason? Again, they are alternate angle. Mark it as equation number 2. Now, in triangle ABC and triangle CDA, angle BCA is equal to angle DAC from equation number 1. AC is equal to CA. Reason is a common side. Angle BAC is equal to angle DCA from equation number 2. So, triangle ABC is congruent to triangle CDA by ASA rule, that is angle side angle rule. Thus, diagonal AC divides the parallelogram ABCD into 2 congruent triangles, that is triangle ABC and triangle CDA, hence proved. Now, let us move on to the second theorem. It states that in a parallelogram, opposite sides are equal. So, given a parallelogram ABCD, construction part, join B to D so that BD forms a diagonal and it divides the parallelogram ABCD into 2 triangles, that is triangle ABD and triangle BDC. We need to prove opposite sides are equal, that is AB is equal to CD and AD is equal to BC. Now, come to the proof. Opposite sides of a parallelogram are parallel. So, BC parallel to AD with BD as the transversal. Angle CBD is equal to angle ADB. What is the reason behind? They are alternate angles. Mark it as equation number 1. Next, AB parallel to DC with BD as the transversal. Angle CDB is equal to angle ABD. Reason, they are alternate angle. So, mark it as equation number 2. Now, take triangle ABD and triangle BCD. You can see that angle CBD is equal to angle ADB. Reason, from equation number 1. BD equal to BD. They are the common sides. Angle CDB is equal to angle ABD from equation number 2. So, triangle ABD is congruent to triangle BCD by ASA rule, that is angle side angle rule. If two triangles are congruent, then all of the corresponding features of the two triangles are going to be congruent. That is, corresponding sides of congruent triangles are equal. So, DC is equal to AB. Similarly, we can prove by drawing diagonal AC, and we can prove that AD is equal to side BC, hence proved. Let's see the next theorem, theorem number 3. In a parallelogram, opposite angles are equal, given a parallelogram ABCD. Construction, join B to D so that BD forms a diagonal and divides the parallelogram ABCD into two triangles, triangle ABD and triangle BDC. To prove opposite angles are equal, that is angle A is equal to angle C, angle D is equal to angle B. Proof. We know opposite sides of a parallelogram are parallel. So, BC parallel to AD with BD is the transversal. Angle CBD is equal to angle ADB. What is the reason? They are the alternate angles. Equation number 1. Next, AB is parallel to DC and BD is the transversal. Angle DBA is equal to angle BDC. Again, they are the alternate angles. Mark it as equation number 2. Now, adding equation number 1 and equation number 2, we get angle CBD plus angle DBA is equal to angle ADB plus angle BDC. Again, we can write it as angle ABC is equal to angle ADC. Or in short, we can write angle B is equal to angle D. Similarly, by drawing diagonal AC, we can prove angle A is equal to angle C. Hence, proved. Let's see the next theorem. Theorem number 4. The diagonals of a parallelogram bisect each other. Given ABCD is a parallelogram with the diagonals AC and BD. Construction. Join BD and AC. Mark the intersection point of AD and BC as O. Now, we need to prove OA is equal to OC and OD equal to OB. Come to the proof part. Since opposite sides of a parallelogram are equal, we can write AD is parallel to BC with the transversal BD. Angle ODA is equal to angle OBC. What is the reason? They are the alternate interior angles. Mark it as equation number 1. Next, AD parallel to BC with the transversal AC. Angle OAD is equal to angle OCB. The reason behind, they are the alternate interior angles. Mark it as equation number 2. Now, take the triangle AOD and the triangle BOC. Angle OAD is equal to angle OCB from equation number 1. AD is equal to CB. What is the reason? Opposite sides of a parallelogram are equal. Angle ODA is equal to angle OBC. What is the reason? From equation 2 we have seen. Triangle AOD is now congruent to triangle BOC by ASA rule, that is angle side angle rule. If two triangles are congruent, then all of the corresponding features of the triangles are going to be congruent. That is, in particular, we can say the corresponding sides of congruent triangles are equal. Thus, we can say OA is equal to OC, similarly OB is equal to OD, hence proved. Test of parallelogram. Using the properties of diagonal sides and angles, you can always identify parallelograms. You need not go through all four identifying properties. If any of these conditions is satisfied, then it is a parallelogram. Conditions are: first one, opposite sides are equal. Second condition, a pair of opposite sides is equal and parallel. Third, opposite angles are equal. Fourth, diagonals bisect each other. Now, we will see each condition. They are stated in the form of theorems. Let's see the proof of each. Theorem. Converse of theorem 2. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Given ABCD is a quadrilateral where AB is equal to CD and AD equal to BC. To prove ABCD is a parallelogram, what is the construction part? We need to join AC, where AC is a diagonal. Now coming to the proof. In triangle ABC and triangle CDA, AB is equal to CD, given. BC is equal to DA, it is also given. AC is equal to CA, they are the common sides. So, the triangle ABC is congruent to triangle CDA by SSS rule, that is side 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 rule. Hence, angle BAC is equal to angle DCA by CPCT. Corresponding parts of congruent triangles are equal. Mark it as equation number 1. Angle BCA is equal to angle DAC by CPCT, that is corresponding parts of congruent triangles are equal. Mark it as equation number 2. Now for lines AB and CD with transversal AC, angle BAC is equal to angle DCA. They are the alternate angle. Lines are parallel, so AB parallel to CD. Now for lines AD and BC with transversal AC, angle BCA is equal to angle DAC. They are the alternate angles. So the lines are parallel and AD parallel to BC. Thus in ABCD, both pairs of opposite sides are parallel. Therefore, ABCD is a parallelogram. Hence, proved. Next theorem, converse of theorem 3. If in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. Given ABCD is a quadrilateral with opposite angles equal, that is angle 1 equal to angle 3 and angle 2 is equal to angle 4. To prove ABCD is a parallelogram, we need to see the proof. By Angle's property of a quadrilateral, we can write angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360 degree. Again we can write angle 1 plus angle 2 plus angle 1 plus angle 2 is equal to 360 degree because it's given angle 1 is equal to angle 3 and angle 2 is equal to angle 4. So, 2 into angle 1 plus angle 2 is equal to 360 degree, or angle 1 plus angle 2 is equal to 360 by 2, which is equal to 180 degree. Mark it as equation number 1. Similarly, we can prove that angle 1 plus angle 4 is equal to 180 degree. Mark it as equation number 2. Now, for lines AD and BC with AB as the transversal, angle 1 and angle 2 are interior angles on the same side of the transversal. So, angle 1 plus angle 2 equal to 180 degree. Since interior angles on the same side of a transversal are supplementary, hence we can write AD is parallel to BC. Next, for lines AB and BC with AD as transversal, angle 1 and angle 4 are interior angles on the same side of the transversal. So, we can write angle 1 plus angle 4 is equal to 180 degree. Since interior angles on the same side of transversal are supplementary, we can write AB parallel to DC. Thus, in ABCD, both pairs of opposite sides are parallel. That is, ABCD is a parallelogram. Hence, proved. Let's see the next theorem, converse of theorem 4. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Given ABCD is a quadrilateral with AC and BD are diagonals intersecting at O. Diagonals bisect each other, that is OA is equal to OC and OB equal to OD. We need to prove ABCD is a parallelogram. Now proof. In triangle AOD and triangle COB, OA is equal to OC. It is a given data. Next, angle AOD is equal to angle COB. What is the reason? they are vertically opposite angles. OD is equal to OB, it's given. So, the triangle AOD is congruent to triangle COB by SAS rule, that is side angle side. Therefore, angle OAD is equal to angle OCB by CPCD, that is corresponding parts of congruent triangles are equal, equation number 1. Similarly, we can prove triangle AOB is congruent to triangle COD and therefore angle ABO is equal to angle CDO by CPCD. Mark it as equation number 2. Now, four lines AD and BC with the transversal AC, angle OAD is equal to angle OCB. They are the alternate angles. So, the lines are parallel, therefore, we can write AD parallel to BC. Now, for lines AB and CD with the transversal BD, angle ABO is equal to angle CDO. Reason, they are the alternate angles. So, the lines are parallel, so AB parallel to CD. Thus, in ABCD, both pairs of opposite sides are parallel. That is, ABCD is a parallelogram. Hence, proved. Next, we will study yet another condition which is the least required condition for a quadrilateral to be a parallelogram. It is stated in the form of a theorem. The theorem statement, a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Given ABCD is a quadrilateral where AB parallel to CD and AB is equal to CD. To prove ABCD is a parallelogram. What is the proof? Let's see. Given AB parallel to CD with the transversal AC, angle BAC is equal to angle DCA by alternate angles. Mark it as equation number 1. Now, in triangle ADC and triangle CBA, AB equal to CD, it is a given data. Angle BAC is equal to angle DCA from equation number 1. Again, AC is equal to CA. They are the common sides. So, the triangle ADC congruent to triangle CBA by SAS rule, that is side angle side. Hence, AD equal to BC by CPCT. Now, AD equal to BC with the transversal AC, we can say angle BC is equal to angle DAC. Reason, they are the alternate angle. Therefore, lines are parallel, that is AD parallel to BC. Thus, in ABCD, both pairs of opposite sides are equal and parallel. That is, ABCD is a parallelogram. Hence, proved. So, let us have a recap of what we have learned about parallelograms. You have seen that a parallelogram is a closed plane figure with four sides. It is a quadrilateral with the two pairs of parallel congruent sides and its four interior angles add up to 360 degree. Then we have discussed specifically about family of parallelogram, that is rectangle, rhombus and square. Also, we have discussed some interesting properties of parallelogram and their proof based on their diagonal sides and angles. Let us have a recap. A diagonal of a parallelogram divides into two congruent triangles. Next property, opposite sides are equal. Third, opposite angles are equal. Fourth property, diagonals of a parallelogram bisect each other. Also, we have seen the test of parallelogram and the conditions are opposite sides are equal. Next, a pair of opposite sides is equal and parallel. Opposite angles are equal. And the last, diagonals bisect each other.